There's a lot of confusion about how UEFI Secure Boot works on today's Intel platforms. In this video, I want to show you three concepts related to Secure Boot: enabling and disabling UEFI Secure Boot, installing your own certificates in UEFI, and demonstrating how firmware behavior changes when UEFI Secure Boot is enabled. I'm not going to explain all the technical nuts and bolts behind UEFI Secure Boot in this video. It's a big pile of documents and it's kind of boring. However, if you want, UEFIDK.com is our Intel UEFI Community Resource Center. We've got a great white paper up there. I'm using that as the reference for this video. Go download and read that document sometime. You'll make the people who wrote it very, very happy. Now, the system I'm using for this video is an Intel DQ57TM UEFI development system. This is based on code out of our Tiano Core EDK2 project, and it has the latest UEFI 231C enhancements, including UEFI Secure Boot. Now, it is a development platform. It has a couple of things that you won't find on your standard motherboard. However, if you look at the menus that I'm going to be going through for Secure Boot, you'll find they're very similar to the ones with platforms that are shipping today with Microsoft Windows 8. Now, I selected this platform for a number of reasons, aside from the fact that it's already sitting on my desk. This platform uses exactly the same crypto package out of EDK2. So if you take the OVMF package from the Tiano Core project, you'll be able to replicate the same results I'm getting without actually having physical hardware. You can do that using a virtual machine, and they describe that process on the Tiano Core webpage. Secure Boot works by only executing UEFI binary images that have been signed by a known certificate authority. These binary images include option ROMs for add-in cards, pre-boot utilities, and operating system loaders. The signature process helps prevent malicious code from executing before the operating system can install its own security mechanisms. Okay, in English, if Secure Boot's enabled, I can only use signed operating system loaders and signed option ROMs, like for video, RAID, or network cards. Now, this means some older add-in cards and some older operating systems can't be used on the system while Secure Boot is enabled. But no worries, Secure Boot is an optional feature. Now, that means I can go into BIOS setup and very easily turn it off, but I'm not a big fan of malicious code, so I want to do this process myself. I want to enable Secure Boot on a fresh motherboard. And since I'm a bit of a control freak, I want to do the process entirely from scratch. First, I'll go into Setup and look at the Secure Boot configuration. Since Secure Boot is an optional feature, not every UEFI system will have it available. It's part of this firmware, but it's not enabled by default. Many systems with Microsoft Windows 8 pre-installed will have Secure Boot enabled. Let's start with a clean system. There's no OS installed, and I just upgraded to the latest version of UEFI firmware. UEFI Secure Boot requires a few certificates to establish a root of trust, and they have to be installed in a user-present configuration. Yeah, that means I have to be standing right here in front of the computer, but that means it's much harder to pull off a remote exploit. Secure Boot needs three basic items before it can be activated. First, the platform key. The PK establishes a trust relationship between the platform owner and the platform firmware. The platform owner enrolls the public half of the key. The key exchange key is the KEK. This establishes a trust relationship between the operating system and the platform firmware. The public part of the key is enrolled in the platform firmware. The KEK can also contain authorized signing certificates. Now, the authorized signing database is known as DB. This is a whitelist of authorized signing certificates and digital signatures. I'd like to set the system up to dual boot between Microsoft Windows 8 and Ubuntu Linux. So that means I need a set of certificates so that both can peacefully coexist on the platform when UEFI Secure Boot is enabled. Now, the KEK and DB that I need for this process are available for free at Microsoft.com. The KEK is for the UEFI Certificate Authority, which is run by Microsoft and VeriSign. There are two DB entries, one for Windows and one for the UEFI CA. Each certificate is available in a CER file format. I'm going to download those to a USB key so I can carry them over to my new system. Now I can use the custom menu for Secure Boot in BIOS setup to install the KEK. I also need to input an associated GUID. I can follow the same steps for the two DB entries, including entering the GUID. The UEFI DB entries allow binaries signed against the UEFI certificate authority to run when Secure Boot is enabled. This means I can use off-the-shelf option ROMs and Linux distributions that were signed against the same KEK. The Microsoft DB entries are specific to Microsoft Windows 8. Remember, you need both the UEFI and Microsoft DB entries for full compatibility. The last step is installing the PK, which is our platform key. I'm going to generate my own PK using OpenSSL. The format of the key is very important. X509 certificate, RS2048 format, DER container file. The first step generates a public-private key pair. The second step takes the public key and converts it to the DER format. That generates a CER file, and that can be loaded by the setup interface. So I copy that onto the USB key and add the PK to the system. Once I enter all the keys into the setup menus, I can take the system out of setup mode and put it into secure boot mode. Okay, this next part is really important. Once you enable secure boot mode, you're not going to be able to run unsigned UEFI binaries anymore. Only signed binaries. That means that any older cards, network, VGA, RAID sort of things, or operating systems, if they don't have a secure loader or signed image, they're not going to run. Things like the UEFI shell won't load from a USB key with secure boot enabled since it's an unsigned binary. On the Intel UEFI development kit, the UEFI shell is part of the signed BIOS image, so it's still accessible, but it won't allow you to run any unsigned code. If you bought a system that's pre-installed with Microsoft Windows 8, there's a good chance Secure Boot is enabled by default. But you still have enough control through the setup menus to go into BIOS and turn off Secure Boot or to manually change the key configuration. So now my system has UEFI Secure Boot enabled. The next step is to install Microsoft Windows 8 and Ubuntu Linux 12.10 so they can dual boot with Secure Boot enabled. I'm going to tackle that in the next video. For more information about UEFI, visit the Intel UEFI Community Resource Center. This is where you can find links to the UEFI specification, the Tiano Core open source project, and lots of educational materials related to UEFI development.